So what we're going to do is we're going to look at this concept of confidence intervals, which are often abbreviated in research articles as just CI. Okay? So what's the idea here? So we just said that a single estimate that we can make by using a sample statistic to estimate a parameter is most likely wrong. Just think about, what's the probability of me throwing a dart at that screen and getting exactly bullseye? Okay, yeah, I can do that with my computer. Well, if you look closely, you'll notice that I didn't even manage to do it exactly. There is still a little bit of a difference between the actual bullseye on that target and where that yellow dot ended up. Okay, so it is very, very difficult to get the exact value. Alright, so what we're going to do, oh, by the way, that means that the probability of getting that value correctly of the parameter that we're estimating is practically zero in every real life situation, right? It's sort of like pretending I can throw a dart at a dartboard and get exactly the center, not just at the center circle, but exactly in the center, okay? So what we're going to do instead is we're going to construct from the data a range of possible values for that parameter. So that will be sort of like throwing at that dart board, not a dart, but a large circle. Okay. Now that circle may end up not really hitting the bullseye exactly in the center. Okay. But notice that even though I went actually reasonably far off, that circle still ended up covering and therefore identifying somehow the center of the target. So that's what we're going to be aiming for. Okay, so what we're going to do is we're going to instead try to construct a procedure that will allow us to catch the correct value with a probability that we choose to begin with. Okay, so let's say I want to construct, I want to do this in such a way that I'm going to be 80% sure that I'm going to catch my parameter, whatever the parameter is. Okay. So this is what we call a confidence interval, okay? And so this is what the whole idea behind confidence intervals is. I could stop here in terms of explaining what the concept is, but there are a few technicalities that we need to go through, so just hang on. Now, in case that theoretical thing with the target with dartboard was not too clear, let me try a different approach. And I'm not saying this is necessarily going to be clearer, but hopefully will help. Okay. Now, so let's say that we're looking for a population mean. Okay, so let's say again, let's think of the mean age of Radio College students. Okay, so that mean age is going to be somewhere on a number line, and what I can do is I can use point estimation. So what does that mean? The population mean is going to be somewhere in there. Think of that as the number line. So that red line indicates a position which indicates the population mean, right? The mean of the mean age of Radio College students. Now keep in mind that I don't know what that population mean is, okay, and I have no way of finding out. That's the whole point of using statistics, right? So what I'm going to do is I'm going to collect a sample and I'm going to see what the sample says. So I collect a sample and the sample will say, well, I guess it's there. Okay, all right. In this case we may be pretty close, but we don't really know how close we are, do we? Okay, so we don't have an idea of whether we're close enough, how likely we are to be close or to be anywhere, right? So I could collect another sample and be somewhere else, which might be further away, or maybe on the other side, or maybe further away on the other side, or maybe even further away, or maybe really totally away. Okay, I don't have a clue. Each sample is going to give me some information, and based only on the sample, I don't know how far away I am from the sample, and I don't know what probability I have of being even close to the sample, to the population mean. Okay. So if I do confidence intervals instead, I start with the same approach. I say, okay, the population mean is somewhere there. Okay, I don't know where it is, but it's somewhere. So I collect a sample and I construct, instead of just a point estimate, instead of a single number, I build up a range of values. Okay, so let's say from my sample data, I can construct a range of number that looks like this. Okay. So my estimate is going to be right here in terms of point estimate, okay? But I'm going to extend my estimation and say, well, I think that population mean is going to be somewhere between here and there. Okay, so in this case, I'm opening up the possibility. I'm not sticking to a single value, but I'm saying, well, I think that my population mean is somewhere in there. Now, I may end up with a different sample giving me different information. So maybe my sample is going to give me this information, but I can do the same thing. I can say, all right, my population, my point estimate is where the blue line is, okay? But I am somewhat convinced, I'm so much confidence, we're going to look at those numbers in a minute, but I have a certain confidence, certain probability that my range of values, so once again going from the left to the right edge of that box, will contain the population mean. Okay? Now, it can also happen sometimes that my confidence interval will not catch the population mean, and I still have to be open up to that possibility. Okay, but at least in this method, I know what is the probability of my box not including the population mean. We're going to come back again to that in a second. And once again, I can get all these boxes being everywhere, and sometimes they're larger, sometimes they're smaller. For instance, this one may correspond to an estimate which is further away from the real population mean, but because of the way I collected it and because of the what the data told me and so on, I may still end up catching the real population mean. And of course, sometimes I may be totally off. So remember, we're still using statistics. There is still the element of randomness. I'm still not totally sure of anything.